Hello folks, welcome to section 9.3 in your notes. This is on composite figures in the Green Holt geometry textbook. As you know, in the past we've been talking a lot about finding the areas of circles, rectangles, triangles, and trapezoids. Today we're going to be taking a look at finding the areas of figures that aren't as obvious. So in this case we have a figure that isn't exactly a rectangle, it isn't exactly a trapezoid. It's something kind of new, or a composition of two figures. So the way that you're going to work with these types of figures is you're going to divide them into the more familiar figures that we're all comfortable with. In this case, I'm going to take a look and notice that I see two rectangles. And I'm going to draw a dotted line to separate them into two regions. One of the regions I'm going to call region B, and the other region I'm going to call region C. I didn't choose those letters for any particular reason, but I wanted to avoid the letter A because I'm going to be finding the area of these regions, and rather than being repetitive with the same letter, I kind of kept it separate. To find the area of the entire region, or the area of the total, and I wrote total as a subscript there, what you have to do is you have to find the area of region B and add the area of region C. So the area of the total is equal to the area of the region B plus the area of the region C. Let's take a look, and I'm going to highlight in red the area of region B. B is a rectangle with a length of 21 centimeters and a width of 15 centimeters, or a width of 15 centimeters and a length of 21 centimeters. Remember, those terms can be interchangeable depending on the orientation of the figure. So I'm going to go ahead and I'm going to find the area of region B by multiplying the length times the width, which in this case is 21 times 15. And now at this point you would grab your calculator, but I'll go ahead and solve it for you. And 21 times 15 is 315 centimeters squared. So that represents the area of your first region. The next region we want to look at is region C, which I'm going to highlight here in green. Now, you'll notice that we don't have complete measurements for region C. We know that the entire length of the base is 27. We know that this part is 15. And so we can use that to figure out the length of region C's rectangle here. If we know the whole length is 27 and this piece is 15, well, 27 minus 15 results in 12. And so this distance is 12 centimeters right here. And then, if we know that this whole length is, if this part of the length rather is 12, and this whole length is 21, 21 minus 12 is 9. And so we know the area of region C is the length times the width, which in this case is 12 times 9. And so in green, I'm going to go ahead and find the area of region C, which is length times width, and that would be 9 times 12, which, when you solve it, comes out to be 108 centimeters squared. Now if you look above, we want to find the region, or the area of the whole region, which I'm now highlighting in blue. And to find the area of that entire region, we're taking the area of region B plus the area of region C. And so the area of the total is equal to 315 centimeters squared plus 108 centimeters squared. I'm just going to box that off because we're just solving this problem right now. And that's equal to a grand total of 423 centimeters squared. Now some of you may have been curious about why I chose to draw a line here and separate them into regions B and C this way. Well, if I were to clear the diagram altogether, I can actually draw the line from here to here and create two other regions, in this case, B and C. And it would have actually worked out to be the right answer. You're welcome actually to erase your diagram and give this a shot, in which this rectangle is 15 by 12, and then you can calculate the length of this and the length of this, and then multiply those together, and you'll see that you do in fact get 423 centimeters squared. Now unfortunately all of them are not going to be as friendly as this one. In fact, many times they're going to be a bit more complicated. Which brings me to example 2, which we're going to go ahead and get started on. So I'm going to erase this, so make sure that you have it written down. You can always pause the video if you'd like. And let's take a look now at example 2. Now, the good news is these dotted lines have already divided our regions up into 3 separate categories. I'm going to go ahead and I'm going to call them B, C, and D. So, if we know that B is a right triangle, C is a rectangle, and D is a semicircle, or half a circle, then we know that these are going to be the three regions that we need to figure out. Now, the hardest part about this, folks, is going to actually be the start of this triangle. Remember that the area of a triangle is 1/2 the base times the height. But in this case, you'll notice that even though we can calculate the height by taking 7.8 minus 3, which incidentally is 4.8, it's very difficult, or at least it appears very difficult, to figure out the base, since we don't actually know it right now with the data we're given. However, some of you may realize that this is in fact a right triangle, which means that, you guessed it, we can use the Pythagorean theorem. So if we don't know the length of this side here, which I'll refer to as x, using the red marker so that you can see what I'm referring to, so x represents this distance here, we can come up with an equation to figure out x by saying that x squared plus 4.8 squared is equal to 10.2 squared. So we go ahead and we simplify that. You would use your calculator. I'm going to do it for you up here as well. And so x squared plus 23.04 is equal to 104.04. Subtract 23.04 from both sides to isolate your variable, in this case x, or unknown, I should say. You end up getting that x squared is equal to 81, and then x is equal to the square root of 81. And the square root of 81, as we know, can be plus or minus 9, but because we're dealing with a geometry problem, we're going to use the positive or principal square root, which is 9. So that seems like an awful lot of work to start, but actually, believe it or not, we haven't even really begun yet. All we did was we found the base, which we now know is 9 feet. Make sure you have some space. It may be advisable at this point to actually take out a separate sheet of paper because this problem is going to take a little bit of work. I'm going to erase this and then begin to solve for the area, but you may want to keep, obviously, everything written down, so you may want to work on a separate sheet of paper. But anyway, we're ready to get started now to figure out first the area of region B. And that's equal to 1/2 times the base times the height. In this case, 1/2 times 9 times 4.8. And when you evaluate that, you get the area of region B being 21.6 feet squared. That gives us the area of region B. The next thing we're concerned with, and I'll highlight this in black, is the area of region C. Well, the area of region C is going to be equal to a rectangle's area, which is the length times the width. And so the area of region C is equal to 3 times 9, which is obviously the length times the width, which comes out to be 27 feet squared. And then last but not least, we have the area of region D, which I'm going to highlight here in green. And that is a semicircle. So that's half the area of a circle. To find the area of region D, the area of region D is equal to 1/2, and if you recall, the area of a circle is pi r squared, so that's 1/2 times pi times r squared. Now, in this case, this whole distance here is equal to this distance here, which is 9. So if the entire distance here is 9 feet, then the radius of our circle, the radius of region D, is going to be half of 9, and so the radius in this case is equal to 4.5. Because we took half of the entire distance 9, and we found that the radius was 4.5. So we go ahead and we plug that in. 1/2. Again, I'm using this half in front because we're not dealing with a whole circle, we're dealing with a semicircle. If it was a whole circle, it would just be pi r squared. We introduced the half because it's a semicircle. 1/2 pi times 4.5 squared. Because we're rounding to the nearest tenth, you can get your answer in terms of a decimal. That's 4.5, isn't it? And when you multiply all of that out, you end up getting 31.8 feet squared. Our final solution now is to take all three of these areas, the area of region B, the area of region C, and the area of region D, and put them together to form the area of the total. And so I'll go ahead and I'll put that over here where I have a little bit of space. And so the area of the total is going to be equal to the sum of each of these areas here, A, B, and C. And so I'll go ahead and I'll write that as 27, 21.6, and 31.8. And when I add those together, I receive the area of the total, which is 80.4 feet squared. And that, ladies and gentlemen, is my final solution.